Hello and welcome to a discussion on multiplying rational expressions. Okay, first I want to think about multiplying fractions, and in this method we will be applying to rational expressions. So if we were to have something like 9 over 16 times 8 over 3, you might have remembered from previous classes or school that you can cancel out. So think about 9 and think straight across from it or on top or bottom. It can never be directly across, but diagonally or top and bottom. 9 over 16, they cannot be reduced to any because they share no common factors, but 9 and the thing across from it, the 3 will actually go into 9. So we can say 3 goes into itself one time, while 3 will go into 9 3 times. Okay, looking at the 16 and the 8, 8 will actually go into 16 2 times, while 8 will go into itself 1 time. So we're actually left with 3 times 1 on top over 2 times 1. And when you simplify, you just get 3 halves, or 3 over 2. So the procedure for multiplying rational expressions are to completely factor the numerators and denominators, simplify by dividing out common factors, and multiply the factors left in the numerators and multiply the factors left in the denominators. So to actually get started by looking at some examples, we have number 1, simplify the rational expressions. Okay, so we have to look out and see, can we factor either 25x over 3, and we cannot, or can we factor 1 over y cubed? And if you look across diagonally, or top and bottom, nothing can be simplified, so we just have to multiply across. So 25x times 1 on top, and on bottom we have 3 times y cubed. Simplifying further, 25x times 1 is just 25x over 3 times y cubed is just 3y cubed. So there was no factoring out for that case, we just simply multiplied across. Looking at number 2, we have 4x to the 4th over 9y times the quantity 45y cubed over 12y cubed. So we have to ask ourselves, can we simplify the 4 and the 9? And we cannot, they share no common factors. And how about the 45 and the 12? And not very prettily, but we can work diagonally. With 4 and 12, 4 can go into itself one time, while 4 can go into 12 into itself 3 times. 4 will go into 12 3 times. Now looking at the variables, you have x to the 4th and x to the 3rd. You can actually think of subtraction, where we have the quantities x to the 4th minus x to the 3rd. So since they share the same base of x, we can just think of bringing the variables together, or the exponents of 4 minus 3 are just x to the 1st, which reduces to just x. So, and we leave the variable to the highest number, or the highest variable with the biggest exponent. So these will cancel out, and on top you're just going to be left with x, 1x. So as you see, the term x, 12x cubed completely canceled out. Now looking at 9y and 45y cubed, we know that 9 can go to itself one time, and 9 can go into 45 5 times. Looking at our variables in this case, we have y cubed minus y, and we can set that's y to the 1st power. So we have y as base with powers 3 minus 1. So we have, simplifying, y squared. So that y is going to cancel out. We have the y cubed canceling out, and of course we'll leave y cubed with the one with the largest variable, so we're just left with x cubed. So simplifying across, we have x times 5y squared over 1 times 3. To simplify, we can actually put the x inside with the 5, so we have 5xy squared all over 3. And that is your final answer. Okay, looking at some more examples, we have the terms 3x plus 3 divided by 7 times 7 divided by x plus 1. Okay, so for this first part, notice there's a 7 diagonally from each other. Those can just cancel out right away, leaving with 1. So we have 3x plus 3 is quantity times 1 over 1 times the quantity x plus 1. And of course you can notice that those 1's can just be written as the fraction 3x plus 3 over x plus 1, because the 1's really do not matter. So you have the numerator, 3x plus 3. You know that 3 will go into both of those terms, so you can pull out a 3, leaving 3 on the outside, and inside you have x, because you say 3x divided by 3 is just the 1x. Then you have plus 3, so you have 3 divided by 3 is just 1. And on the bottom you have the quantity x plus 1. So you notice that x plus 1 is on top and bottom, leaving you with just 3 as your solution. Okay, looking at some more examples, we have 10x over x plus 2 times the quantity 4x plus 8 over 2. First thing you want to note is that 10 and 2 can cancel out diagonally here. 2 can go to itself 1 time, and 2 can go into 10 5 times. So if we just want to rewrite this as 5x over x plus 2 times 4x plus 8 over 1. Okay, if we look, 5x and x plus 2 cannot be reduced, so we have to work diagonally. We see that 4x plus 8, that both terms can be reduced, saying that 4 can be brought into each term. 4 and 8 can be divisible by 4, so in this first part, 4x divided by 4 just leave you with 1x, or just x, and plus 8, so 8 divided by this 4 we're factoring out leaves us with just a positive 2. So we can leave that part out. And note that the term x plus 2 occurs on top and bottom, leaving you with just 1 in each case. So it leaves you with 5x times 1 on top, and on bottom you have just 1 times 1. We're just left with 5x as the solution. And finally, we have what looks to be a mess, but we can clearly work through this. Let's just start by factoring this first term, which will be done in black. Okay, so for this first part here, x squared minus x minus 12. The coefficient of 1 in for x squared tells us to just go ahead and write our open parentheses with x's inside. Notice that 12 is negative, so that tells us to write a positive and a negative. Okay, now you have to think of things together that multiply to give you negative 12, that when adding give you a negative 1, because there's a 1 right there for that coefficient of negative x. So if you think about it, actually negative 4 and positive 3 multiply to give you negative 12, but if you add negative 4 plus 3, you get negative 1. Okay, looking at the denominator, we have x squared plus x minus 2. So that can be broken down into these two sets of parentheses with x in the beginning of both. Okay, again, this is a minus, so we're going to have a plus and a minus. So what are the factors of 2 that when multiply give you a plus 1, and that's a negative 2, excuse me. So if you think about it, how about a negative 2 and a positive 1? Because negative 2 times 1 is negative 2, and if you combine negative 2 and 1, you get negative. You get a plus 1. Well, you'd actually get a negative 1 in that case. So we actually want to flip what we have. Reverse. So we have 2 being positive and 1 being negative. Okay, looking at the numerator on the second terms, we have x squared plus 3x plus 2. So let's break our factoring down into just open parentheses with x inside. Okay, we have a plus in for the last term, and that tells us to use the same terms in the middle piece. So that's positive, so both of these will be positive. So now we think of things that would multiply to give us 2 that add to give us 1. So that would be a positive 2 and a positive 1. And finally, for this bottom denominator right here, x squared minus 2x minus 15, let's break our parentheses apart with x opening in both pieces. Since 15 is a negative, that tells us to have a positive and negative in for each piece. So what are the factors of 15 that when adding them give us a negative 2? What if we have a negative 5 and a positive 3? Because multiplying those together would give you a negative 15, but combining positive 3 and negative 5 would give you a negative 2. Okay, so now let's go through and let's identify what occurs in either set. X plus 3 does not occur on the bottom, it occurs on the top, and diagonally it occurs right here. So these are canceled out. Okay, x minus 4 only occurs one time. Okay, so we look on the bottom, we have x plus 2 occurs here, and it occurs diagonally across from it. And everything that's highlighted here simplifies. Everything that is not highlighted will be left behind, so I have x minus 4 the quantity times the quantity x plus 1 over the quantity x minus 1 times the quantity x minus 5. And that is the solution.